right? So look at the question. The response of the system G of S is equal to S minus 2 by S plus 1 into S plus 3. To unit step input U of t is Y of t. The value of dy by dt at t is equal to 0 plus is, right? Y of t is step response, right? What is dy by dt? Dy by dt is differentiation of y of t is what? This is nothing but differentiation of step response. What will you get? You will get impulse response. Impulse response. So what you people generally will do, I'll tell you what you people generally will do. That is, you will just give an impulse input to the system. What is your system G of S? You will give impulse input to the system, that is del of t. Del of t, if you are giving R of t is equal to del of t, which means R of S will be is equal to what? 1. You will get C of S as G of S. C of S will be is equal to G of S. In order to find out C of t, what you will do, you will Laplace inverse on C of S and you will put t is equal to 0. T equals 0 plus, right? This is one way you will do, right? But even you have a very much simpler form, right? See, Laplace transform of impulse response is nothing but your transfer function, yes or no? Laplace transform of impulse response is equal to what? Transfer function. Laplace transform of impulse response is nothing but transfer function, right? So initial value of impulse response, limit t approaches 0 plus impulse response is equal to limit s approaches infinity s into G of S. G of S is nothing but the transfer function of the system. That's simple. You just put this particular limit in that, you will get the answer, right? So substitute s approaches infinity in this particular transfer function, right? Limit s approaches infinity s into s minus 2 divided by s plus 1 into s plus 3. S plus 1 into s plus 3. If you put s is equal to infinity in this, you will get infinity by infinity form, right? You will get infinity by infinity form, which means you have to just take s as common from numerator and denominator. You just take s common from both numerator and denominator. Then you will get s square into 1 minus 2 by s divided by 1 plus 1 by s, 1 plus 3 by s into s square. Limit s approaches infinity. Is it visible to everyone? Right? So if at all it is not visible, please let me know. Right? So in this way you will find out the limit. This s square and s square gets cancelled. If you put s is equal to infinity in this will become what? 1 minus 0 divided by 1 plus 0 multiplied by 1 plus 0. That is equal to 1 simply. The unit impulse response of a system is h of t is equal to e power minus t. For this system, the steady state value of output for unit step input is equal to. So see here, impulse response h of t is given. H of t is equal to what? That is e power minus t. E power minus t for all t greater than 0. Here multiplied by u of t is not needed to be given because he has given for all t greater than or equals 0, right? Therefore, what is the transfer function of the system? Transfer function of the system, let us say h of s is equal to 1 by s plus 1, right? So what is the step response? See, to this particular transfer function, to this particular system, we have given a step input. What is step input mean? What does step input mean? R of s is equal to 1 by s. Right, that is what is given in the system, right? For this system, the steady state value of output for unit step input is, right? Impulse response is given and the steady state value of output for unit step input is asked, right? So see here, so if C of S is our output, then what is C of S? C of S is 1 divided by S into S plus 1. This is C of S. So steady state value means final value. Final value means limit s approaching 0, s into, right, s into c of s. That is equal to what? Limit s approaching 0, s into 1 by s into s plus 1. S gets cancelled. If you put 0 in this, you will get 1. Right? So this question can be solved in various other ways also. Right? So this is the simplest approach. We still have other approaches also. Let us say, so let us look at another approach. If h of t is our impulse response, if h of t is our impulse response, that is e power minus t, right? So how will we get our step response? Step response will be nothing but integral of impulse response. Let us call c of s as our step response. Step response c of s is equal to what? C of s will be is equal to h of t dt. Right? If you integrate this, what will you get? You will get e power minus t. Sorry, minus e power minus t plus k. Some integration constant will also be there. Right? So you have to find out this particular integration constant. So you have already seen, see, you can easily guess that it is an all pole system, right? This system has only poles but no zeros, right? So for all pole systems, you have seen the response. We have seen the response previously. The step response of an all pole system starts at 0 and finally it approaches the value of the input, right? Whatever might be the value we have given, right? So the initial conditions, you can apply the initial conditions in order to find out the value of k. Yes or no? Is it clear, everyone? In order to find out the value of k, you can use initial conditions, right? At t is equal to 0, what is the value of the response? At t is equal to 0 or 0 plus, you can say, what is the value of the response? At t is equal to 0, the response is equal to 0. Put t is equal to 0 in this, you will get k is equal to what? K is equal to 1. Therefore, the step response of the system is c of t, sorry, this is c of t. C of t is equal to minus e power minus t plus 1, right? So in order to find out the final value of this, you have to put t is equal to infinity in this, right? If you put t is equal to infinity in this, what will you get? You will get the response to be is equal to 1. The final value of the response to be is equal to 1, right? So this is the simplest approach you can use. I'm just telling you various ways of solving this particular question, right? So you can use this approach also, right? So one thing you must note here is the initial value of the response, right? The initial value of the response is 0, right? Because we have already seen such responses previously, right? These kind of responses started at 0 and reached 1, right? Reached their final value. So if you have any doubts in this, you can ask, right? The initial, I'll let you write a note later on that the initial value of the system will be 0 only for all pole systems. If there are any zeros in the system, then initial value may not be 0, right? See, the value of the method of using KDC is nothing here. See, what is the transfer function you got? Transfer function is h of s is equal to 1 by s plus 1, right? So to this particular system, 1 by s plus 1, we are giving a DC input. What is the DC input? Step input. Step input of what magnitude? The magnitude of the step input is 1, right? So what will be the output? Output will have a magnitude of how much? Output will have a magnitude of kdc into the DC input, right? DC gain multiplied by the DC input. DC input is how much? 1, right? So it is not necessary that this is a plain DC like a step, right? It is some exponential thing like this, right? But the final value of the response is going to be kdc into 1. What is kdc here? You just have to find out kdc, right? How to find out kdc? Kdc will be is equal to, if you put 0 in this, If you put 0 in the transfer function, you will get KDC. S is equal to 0, right? So put S is equal to 0, KDC will be is equal to 1. If KDC is 1, then final value of the response is also 1. So let us go with the next problem now. This problem. So let us look at the question. The unit step response of a negative unity feedback system with the open loop transfer function. Open loop transfer function G of S is equal to 6 by 5 is, right? So he has clearly mentioned here, see, he has clearly mentioned G of S is what? G of S is open loop transfer function, that is not the overall transfer function, right? So G of S is the open loop transfer function of this particular system, this particular closed loop system, right? So this is the open loop transfer function of this unity negative feedback system, right? So he was asking the unit step response. Unit step response is what is needed, right? So if you are feeding unit step input, that is R of S is equal to 1 by S. If you are feeding this input here, what is the output? That is what is asked. So what is the overall transfer function for this? See, overall transfer function for this is nothing but G of S by 1 plus G of S. That is equal to 1 by S plus 5 divided by 1 plus 1 by S plus 5. If you simplify, you will get 1 by S plus 11, right? So S plus 5, right? So if at all you find out the overall transfer function, 6 by S plus 5, right? 6 by S plus 5, 6 by S plus 5, 6 by S plus 11. So this is what you are going to get, right? So if this is your transfer function, you have to find out C of S. C of S is equal to 6 by S plus 11 multiplied by S, right? Therefore, C of T is Laplace inverse of C of S. If you find out Laplace inverse of C of S, you will get 6 by 11 minus 6 by 11 e power minus 11 t multiplied by u of t, right? So this is one approach, and one more approach is, see, once you get the transfer function, this is your transfer function, overall transfer function of the system is this, right? So if you know this transfer function, what is the impulse response? Impulse response is 6 e power minus 11 t, yes or no? Impulse response of this is going to be 6 e power minus 11 t. If you have impulse response in your hand, what is the step response? Integration of impulse response is nothing but step response. Just integrate. Step response is equal to integration of impulse response, that is equal to integral 6 e power minus 11 t dt. That is equal to how much? Minus 6 by 11 e power minus t plus k. So how will you find out k? Tell me. How will you find out the value of k here? By putting t is equal to 0. If you put t is equal to 0, the initial value of the response is going to rise from 0 only, right? Because this is an all pole system. This system has only poles but no zeros. If there are any zeros, the initial conditions might be different, right? But if there are only poles, the initial conditions will be something like this, right? Therefore, if you put k is equal to t is equal to 0 in this, you will get k is equal to 6 divided by 11. Therefore, impulse step response is equal to 6 divided by 11 minus 6 divided by 11 e power minus 11 t. This multiplied by u of t. This will be the step response actually, right? So did everybody get this? So take down a note here. One important point to note here is step response starts at 0 for only for all pole transfer functions, right? So take down this particular note. This will be useful to you in some shortcuts, right? So if at all you want to apply some shortcut approach, you might be using this approach. Then, so you must remember that step response will be starting from 0 only for those transfer functions which will start from, which have all poles, right? No zeros. All poles only, no zeros, right? Step response starts at 0 only for all pole transfer functions, right? So see here, we have integrated impulse response in order to get step response, right? So what did we assume in order to find out the value of k? At t is equal to 0, the value of the response is 0. This is what we have assumed, right? So let us say we have assumed our response to be something like this. It is starting at 0 for t is equal to 0, like this, right? So the step response may not start from 0 if it is not an all pole transfer function. It might start somewhere from here if it is not an all pole transfer function. The initial conditions are not 0, whereas here the initial conditions will be 0. You cannot say initial conditions, that is initial value of the response. Initial value of step response is 0 only for systems having all poles. If there are any zeros, it might not be 0, right? So did everybody get this question also? Shall we move on to the next? So you have this particular block diagram. So in order to convert this particular block diagram into a signal flow graph, yes, in order to convert this particular block diagram into a signal flow graph, just give names to each and every summing point as well as the takeoff points, right? If you give names to each and every summing point and takeoff point, then it becomes very easy in order to solve any complex signal flow graph or complex block diagram into a simple one, right? So see here, we have two takeoff points at the end, we have two summing points just before them, right? Therefore, see, I'm just indicating each and every one with a single node. So before those two summing points, we have one more takeoff point. Yes or no? We have one more takeoff point just before those two summing points, right? So between these two summing points, let us call these as 1, 2, 3 and 4, right? So between 1 and 2, we have P. Between 1 and 2, we have P. Between 2 and 3, we have 1 by S. Between 3 and 4 also we have 1 by S, right? So before 4, what do we have? We have one more takeoff point, right? So you can also take the takeoff point from the downwards also, or else one thing you can do is, see, just take this summing point. Summing point is just above this node, right? The third one, above this, there is a summing point like this, right? So just call it as sum 5. So connect this 3 and 5. Between this 3 and 5, you have a unity gain branch. What is that? It is a unity gain branch, right? So between 5 and there is one more node here, B not connected in between 4 and 5, let us say, right? So between 5, sorry, this is 6. Between 6 and 5, there is B1 connected. Between 6 and 5, what is connected? B1 connected. And what is the direction? This direction, right? There is one more node available here. That node is, you can take that node to be downwards also, or else you do one thing, take C0 in between 6 and this, and take C1 in between 6 and 5, right? So here in the downward stage, you can take this B1 and B0. Between B0 and the first stage of this integrator, we have, what is the gain of this? Gain of this is from here to here, we have B1, B0, B1. So between 2 and this, we have A1. Between this and this, we have 1. And between this and this, we have A0. Between this and the one connecting B0, right? So where are we giving the input? Input we are giving at C0 and C1, right? to C0 and C1 we are giving the input, which means this is your output. Once you got signal flow graph, you will get everything, right? So you can rearrange this to be in a simplified manner also. You can rearrange the block diagram in a simplified manner also, and then also you can get it. So once you get the signal flow graph, like this, you will get the overall transfer function, right? So once you get the overall transfer function, you have to compare the overall transfer function with the scheme given here, right? So what is the scheme given here? It is some x. After this you have a summing point, and this is connected to y, and after y we have, and after t we have, sorry, this is given to be plus. So if you reduce this, what is the overall transfer function of this you are going to get? That is yp into x divided by 1 minus ypz. So this is the overall transfer function, right? So when you get the overall transfer function of this using signal flow graph approach, how will you get it? Using Mason's gain formula. Mason's gain formula says it is 1 upon delta sigma pk delta k. It is pk delta k, where k runs from 1 to n, right? So if you just use the Mason's gain formula in order to get the entire transfer function, and if you compare them, you will definitely get the values of x, z, y and x, right? Go to the next problem. The block diagram of a system is shown in the figure. If the desired transfer function of the system is C of s upon R of s is equal to s by s square plus s plus 1, then G of s is. So let us proceed with the question, whatever it is, right? So the question is given like this. So we'll directly convert this into a signal flow graph, right? 1 by s is the transfer function from here to here, and between this and this, G of s is connected. Between this point and this point, s is connected, and from this point to this point, minus 1 is connected. From this point to this point, minus 1, and also from this point to this point, minus 1 is connected. So R of s input is provided here, output is taken here. So this is the signal flow graph, right? So from the signal flow graph, you can get the transfer function easily, right? How many forward paths are there? There is one forward path, which means n is equal to 1. Therefore P1 is equal to what? P1 is simply G of s. I'm just writing it as G for simplicity. P1 is equal to G, right? How many loops are there? There are 3 loops you can see, right? The first loop that you can see is L1 is equal to minus SG, and L2 is equal to minus G, L3 is equal to minus G by S. So these are the loops. So delta 1, there are no non-touching loops to the first forward path, therefore delta 1 is simply 1. Look at delta. Delta is equal to 1 plus SG plus G plus G by S, right? So this is delta. So obtain delta completely, that is, you will get G in common, G into S square plus 1, S square plus S plus 1, it is G by S plus 1, right? So this is delta. So obtain overall transfer function M is equal to P1 delta 1 upon delta, that is equal to G divided by G by S into S square plus G plus 1 plus 1, right? So you will get S divided by S square plus 2S plus 1 multiplied by G. So there must be 2S in the denominator, yes or no? Sorry, I can't take this S to be common. This is S into G. So this S requires a G in multiple, right? Only then I can get the answer, right? So in order to get this, G, if you put G is equal to 1 in this, if you just put G is equal to 1 in this, let us say G is equal to 1, it is S divided by S square plus 2S plus 1. This is what is required. But the answer given by the GATE board is G is equal to S. This is given by the GATE board. So this is an add score for all. There was a mistake in the question. The question was given to be wrong, right? If G is equal to 1, then only you will get S by S square plus 2S plus 1. And that is also not matching with the transfer function given in the question. The transfer function given in the question is what? It is S divided by S square plus S plus 1, right? We still miss a 2 here, right? And also we miss G to be equal to 1. So if this is a question which has a slight mistake in that. If you put G is equal to S, the transfer function you would get is S square by S cube plus 2S square plus S plus 1. So G cannot be S here. Right? Anyways, the question given is wrong actually. Right? The options given in the question were completely wrong. Not only options, the question, that is C of S by R of S, the transfer function given by them is wrong. Is it clear? So what is the signal flow graph we got? The signal flow graph we have constructed is something like this, right? So we have given names for points. Between 1 and 2, P is connected, and between these two, 1 by S is connected. Between these two, another 1 by S, and before 1 by S, is there anything? No, right? So from here to here, minus A1 is connected. From here to here, minus A0 is connected, and between these 2 points, what is connected? B0 is connected. Between these 2 points, B0 is connected, and between this point and another summing point, right? We can indicate that with a separate node, right? So there is a separate node connecting between these 2 integrators. Its gain is how much? 1, right? So to that node, this P is connecting B1, right? From here to here, what is connected? B1 is connected, and from this point to this point, to this C1 is connected, and to this point C0 is connected like this. So this is where we are giving the input. This is 1, this is R of S, right? This is C0, and this is C1. So this is the signal flow graph for the given block diagram, right? The previous signal flow graph we got, that was also same, right? So just it was a little rearranged, that's it, right? So did everybody get this signal flow graph? You got this particular signal flow graph, right? So how many forward paths are there in this? There are 2 forward paths, right? The first forward path, yes, Shikha, Shubham, very good. The first forward path is P1 is equal to C0 into 1 by S into 1 by S into P, that is C0 P by S square. You got C0 P by S square. What about P2? P2 is this forward path, C1 P by S. C1 P by S. So what about delta 1 and delta 2? Delta 1 is 1 because there are no non-touching loops to this particular forward path, first forward path, and there are no non-touching loops to the second forward path also. Therefore delta 2 is also is equal to 1, right? So once we get this, we need to calculate delta. Delta is 1 minus summation of all the loops, right? The first loop is, you can see here, that is A1 by S. Minus of minus A1 by S, it is plus A1 by S. And minus of minus A0 by S square, that is plus a naught by s square, right? So what about the next loops? It is b naught into 1 by s into 1 by s into p, right? So it is b naught p by b1 p by s plus b naught p by s square. So not plus, sorry, we are subtracting this. This is not minus b naught, this is plus b naught, and this is plus b1, right? So these are the loops, and this is delta. There are no non-touching loops at all the loops are touching each other, right? This loop is touching this one, whereas this loop is touching both these, and this loop is touching these two, right? So all the loops are touching each other. There are no non-touching loop pairs or triads in this, right? So this is delta. So once you got this, what is the overall transfer function? Overall transfer function is m is equal to p1 delta 1 plus p2 delta 2 divided by delta. Therefore, p1 delta 1, that is c naught by s square plus c1 by s, and p in common, divided by 1 plus a1 by s plus a naught by s square minus b1 p by s minus b naught p by s square, right? So from this you can take p to be common. You can take p out of this. This is minus of this. So if you just simplify this, you will get a form. And before this, you have to simplify this into this block diagram only, right? So what is this block diagram? What is the overall transfer function of this particular block diagram that is shown in the slide now, right? The overall transfer function m is, let us say, it is x, y, p divided by 1 minus x, sorry, not x, y, z, p. 1 minus yzp. You have to reduce this into this form, right? Then you can compare both of them. You can get the values of x, y, and z, right? So in order to reduce it into this form, just simplify this, right? So this is c naught plus c1s multiplied by p divided by s square plus a1s plus a naught minus b1s plus b naught, and 1 divided by s square in the denominators of numerator as well as this denominator, they get cancelled, right? You will be left with this, right? So do one thing, divide the numerator and denominator with s square plus a1s plus a naught. So just to convert this into this form, that is what I am doing, right? In order to convert this into this form, I am just dividing the numerator and denominator with this particular factor, so that I'll get 1 here, 1 minus something, just like this, right? So divide numerator and denominator by this particular factor, right? Therefore, this will be equivalent to what? C naught plus C1s into P divided by S square plus A1s plus A naught divided by 1 minus B1s plus B naught divided by A1s plus, S square plus A1s plus A naught multiplied by P, right? So just compare this with this, you will get the answer, right? So upon comparing these two, what are you getting? See, this y is common in both numerator and denominator. So y is nothing but 1 by s square plus a1s plus a naught. You can say y is equal to 1 divided by s square plus a1s plus a naught. And what about x? If 1 by s square plus a1s plus a naught is y, then x will be equal to what? X will be equal to c naught plus c1s. And what about z? Z will be equal to b1s plus b naught. right? B1S plus B0. So which option is matching these? X is equal to C1S plus C0, Y is equal to 1 by S square plus A1S plus A0, and Z is equal to B1S plus B0. Which option is matching? Option D. Option B. So just solve this particular problem. For the system 2 by S plus 1, the approximate time taken for a step response to reach 98% of its final value is. See, what is the time taken to reach 98% of its final value? Is it the 4% tolerance settling time? TS for 2% tolerance is equal to how much? 4 times of time constant. What is the transfer function given here? Yes, 4 times of time constant. Very good. The transfer function given here is 2 by S plus 1. Just compare it with the standard transfer function, that is KDC by ST plus 1. So what is T here? T is equal to 1 second. If T is 1 second, then settling time TS will be equal to how much? 4 times of 1, that is equal to 4 seconds. Very simple problem. It is 4 seconds. So take down the question here. The position control for of a DC servo motor is given in the figure. The values of the parameters are Kr is equal to 1 Newton per meter, Ra is equal to 1 ohm, La is equal to 0.1 Henry, J is equal to 5 kg, and B is equal to 1 Newton meter. Kb is equal to 1 volts. Kr is equal to 1, Ra is equal to 1, La is equal to 0.1, and J is equal to 5, B is equal to 1, Kb is equal to 1. So the transfer function is like this. This is the transfer function, and you have to find out the steady state position response, that is theta in radians due to unit impulse disturbance. So all the things are given here itself. So in this transfer function, you just have to substitute their values. That's it. So what is given here? It is KT. Sorry, this is not KR, this is KT only. That was printed wrong. This is KT. KT is how much? KT is 1. Therefore it is 1 divided by RA is 1. 1 plus 0.1S. 1 divided by 5S plus B. Value of B is 1. 1 by S. Value of KB, how much is it? KB is 1. So for disturbance input they have asked steady state position response due to unit impulse disturbance TD, right? So if TD is unit impulse, TD is equal to del of T, then what is theta of S? That is what you need to find out, and that is very simple here, right? No signs are given here, they are actually plus. So this is the transfer function, and you have to find out the value of theta S. Please take a screenshot of this. You just need the final value of theta S. What do you need? You need limit S approaching infinity S into theta S. Final value of theta S is what is needed. Steady state value of theta S is asked. Right? If TD is TD in time domain, TD is disturbance input is del of T, then in frequency domain, that is in S domain, this will be is equal to 1. So theta S, if at all you want theta S for disturbance input TD, then you have to make it 0 only. I have straight away made VA of S to be 0. Therefore it is simply TD of S here, and theta of S is our output. We are just removing this input because the output theta of S for TD of S is only asked. Only this part is asked, which means whenever you have more than one sources, what you will do, you will use superposition, right? If the output because of this source is asked, then this input has to be assumed to 0, right? If at all you assume this to be 0, what is the gain of this? You can say the effective gain of this is -1, and that is the reason I can multiply this with -1, or else whatever the signal that is coming from here, let us say x is coming from here, the same x will come here also, right? So this x is fed to this, so x multiplied by this, x multiplied by some y is the signal here, right? So this will be a negative sign, yes or no? Because 0 minus x and minus xy. So simply what I've done is I've transferred this negative feedback from here to here, that's it. So that is the reason why I got this negative feedback. Is it clear? You can do a plus b directly, or else you can do a plus of minus b, right? The same is happening here. So this negative feedback somewhere will be transferred from here to here also. So see here, I'm just solving it. Therefore, theta of s will be is equal to, what is input? Input is just 1 multiplied by, what is the overall transfer function? Overall transfer function is 1 by 0.5s plus 1 divided by 1 plus 1 by 0.5s plus 1 multiplied by 1 plus 0.1s, right? So you will get 1 plus 0.1s divided by 1 plus 0.1 into s multiplied by 0.5s plus 1 plus 1. This is theta of s. Final value of theta of s, how will you find it out? Limit s approaching 0, s multiplied by this, right? So if you put s in this, in order to put, if you put s in this, you will get simply 0. Therefore, theta of s is 0. The answer is 0 divided by 0 plus 1. That is equal to 0. Yes, 1 by s is also there, right? Thanks for reminding. So it is 1 by s multiplied by the overall transfer function, right? This s will cancel this s, right? So if you put s is equal to 0 in this, what you will get? You will simply get, if you put s is equal to 0 in this, the answer is not 0. Just put s is equal to 0 in this, you will get 1 divided by, this is 1 multiplied by 1, this is 0.5. This is the exact answer. So in order to solve this problem, you need to know about the second order systems. So we so far we have done the analysis of first order systems only. Let us go for second order systems now, right?